directly if you go to the chapter number 2. So in the case of the chapter number 2, the chapter number 2 is nothing but whom? Physical properties and basic definitions. So in the case of the physical properties and basic definitions, so we took the soil element, and in the soil element, we said that soil consists of solids and voids. Those voids are gets filled with whom? Either air or water. So in a given soil, it is a partially saturated state. There is a solids, there is a water, and there is a air. Yes. So I have been discussed this one by using one phase diagram. Now let me show those also. Yes. So by using this phase diagram, in the case of your deep learn, I have explained with some animated videos. Yes. So generally the physical properties in the case of the soil, so whatever these are nothing but the solids, and this is water, and this is going to be air. So this is going to be converted into a block diagram. Idealization is a three-phase diagram. Now, as it is a complex system to analyze, we converted the complex soil into a idealized three-phase diagram or a block diagram by keeping the solids at the bottom and air at the top. And now, by using this, we mentioned on one side volumes and other side are weights. So whatever, this is nothing but the volume of solids. Here it is going to be volume of water, and here it is going to be volume of air. And then we discussed here, this is nothing but the weight of solids, weight of water, and weight of air, which is neglected, so it is going to be 0. So the total volume here, this is the total volume. So whatever here, this is nothing but the volume of voids, and here it is going to be total volume. Similarly, the total weight is going to be WW plus WS. So by using this phase system, we have defined all the things in the physical properties. So first, coming to the basic definitions, what is a void ratio? The basic definitions are going to be void ratio. What is void ratio? How many volume of voids are there with respect to the solids? How much voids are there with respect to the solids? Volume of voids to volume of solids. And what about the next porosity? Porosity means the percentage of the voids, which means voids in the total soil. So what is the voids in the total soil? VV by V into 100. And what is the relation between the void ratio and porosity? Both are representing the voids. So N is equals to E by 1 plus C, or E is equals to N by 1 minus M. Okay, so this is number one, void ratio, and number two, porosity. And what is the relation between the void ratio and porosity? So N is equals to E by 1 plus E, or E is equals to N by 1 minus N. The most commonly asked 1 mark question from this chapter is a relation between the void ratio and porosity. I would be giving, if the void ratio of the soil is 0.5, what is the porosity? If the porosity of the soil sample is 1, then what is the void ratio? So first, basically with respect to the voids, and then coming to the third one, degree of saturation. How much water is present in the voids, which means VW by VV into 100. And how much air is present in the voids, which is going to be VA by VV. That's going to be air content, VA by VV into 100. So now what is the relation between SR and AC, sir? SR plus AC is equals to 100%. SR plus AC is equals to 100%. So always the summation of degree of saturation plus air content is going to be 100%. These are small details that makes a lot difference. Okay. And next, percentage air voids. See, air content means how much air is present in the voids, but air voids means how much air is present in the total soil. So how much air Va in the total soil Va by V into 100. As air content and air voids both are represent air, what is the relation between air content and air voids, sir? Na is equals to N into AC. Na is equals to N into AC. Okay, so this is the relation. And finally, what about the water content? On the weight side, water content W is equals to weight of water by weight of solids into 100. So these are the basic definitions we have been discussed. And then once we discuss the basic definitions, see from here we discussed about the unit weights. Yes or no? And you know that if this soil mass is going to be, means at this state, this is a partially saturated, right? This is nothing but the partially saturated. There is nothing but the partially saturated. Now, if you allow it to dry, then the water in the voids will escape, but the total volume remains same. Na? So water will escape, air will come. Such a state is nothing but dry state. And if you soak the soil, then it is going to be fully saturated. So basically, for a given soil, how many states are there? If the entire voids are filled with water, fully saturated. If voids are filled with air, dry state. And both the water and air, partially saturated. So once we know this, then if you come to the unit weights, so in the case of the unit weights, if it is going to be a partially saturated or bulk unit weight, partially saturated unit weight, represented with the gamma, right? What is this gamma? Total weight by volume. That's it. And second one is a fully saturated unit weight. So fully saturated is gamma sat, which is W sat by total volume, no change in the volume. And dry state, gamma D. Dry weight by volume. What is the meaning of dry weight, my dear? If you dry the soil, then only weight you are going to see is only the solids, right? So dry weight is nothing but the weight of solids by volume. Yes. And apart from the three unit weights, there is a one more unit weight known as a submerged unit weight. There is one more unit weight known as submerged unit weight. So I told you this submerged unit weight is based upon the Archimedes principle. Submerged unit weight represented with gamma dash, and the gamma dash is nothing but gamma sat minus gamma W. Okay, so you know that when do you say a soil is submerged? Whatever the soil below the water table, that is a saturated and a submerged. Why? According to Archimedes principle, when you immerse an object or a solid into water, this water will apply an upward resisting force known as buoyancy due to pressure difference. Buoyancy is due to whom? Pressure difference. So if the body is below the water table, due to the pressure difference, an upward force is offering known as buoyancy. And whatever the weight of water displaced by immersing that object is nothing but a buoyant force. If you immerse